Ladies and gents, my name is Brandon Stover. Welcome to the How to Solve Climate Change course from Plato University. Causes, systems, obstacles, solutions to this global challenge is what you're going to learn here today. When you're ready to learn more skills, join us for free at plato.university. Let's get started with today's lesson. Explain succinctly what natural sources of carbon are from first principles.
Natural sources of carbon refer to the release of carbon dioxide and other greenhouse gases into the atmosphere through natural processes, not directly caused by human activities. These sources include natural phenomena such as volcanic eruptions, wildfires, decomposition of organic matter, and respiration by living organisms. Natural carbon emissions have been part of Earth's carbon cycle for millions of years and are balanced by natural sinks, like forests and oceans, which absorb and store carbon.
Why is natural sources of carbon a problem that causes climate change?
While natural sources of carbon have always been present in the Earth's carbon cycle, human activities have significantly increased the concentration of CO2 in the atmosphere. Burning fossil fuels, deforestation, and industrial processes release vast amounts of additional CO2 into the atmosphere, upsetting the natural balance. As a result, the atmosphere's capacity to absorb and store carbon is overwhelmed, leading to higher concentrations of GHGs, particularly CO2 and methane. These additional GHGs trap more heat from the sun, causing the Earth's average temperature to rise, leading to global warming and climate change.
Why is natural sources of carbon important to address? What's at stake if we don't address it?
Addressing natural sources of carbon is important for several reasons. Natural sources of carbon make up our baseline emissions. While human activities significantly contribute to climate change, natural sources of carbon are a critical part of the carbon cycle. Understanding and quantifying these natural emissions helps establish a baseline against which human-caused emissions can be measured and evaluated. Another concern is how climate feedback loops are affected. Climate change can trigger feedback loops within natural systems, causing them to release more carbon. For instance, as the Earth warms, permafrost in the Arctic thaws, releasing large amounts of trapped methane, which, in turn, accelerates global warming. However, studying natural sources can give us a clue into climate resilience. Protecting and restoring natural carbon sinks, such as forests and wetlands, is essential for building climate resilience. Healthy ecosystems can absorb and store more carbon, mitigating the impact of human-caused emissions. Of course, addressing natural sources is key for scientific understanding. Accurate accounting of natural carbon sources is crucial for climate modeling and improving our understanding of the complex interactions between the Earth's climate and its natural systems. If we don't address the impacts of natural sources of carbon, it could exacerbate climate change and further disrupt the Earth's delicate climate balance, leading to more extreme weather events, sea level rise, ecosystem disruptions, and threats to human well-being and biodiversity.
How might we eliminate or mitigate the problems of natural sources of carbon?
While we cannot eliminate natural sources of carbon, we can take several actions to mitigate their impact and work towards a balanced carbon cycle. First, we can focus on conservation and restoration. Protect and restore natural carbon sinks, such as forests, wetlands, and mangroves, which can sequester and store large amounts of carbon. Doing this will require sustainable land management. Implement sustainable land management practices that promote carbon sequestration and reduce emissions from natural sources, such as controlled burns to prevent uncontrolled wildfires. We must also look at climate adaptation. Develop strategies to adapt to the impacts of natural carbon sources, such as enhancing climate-resilient agriculture and coastal protection measures. Finally, we want to continue the scientific enterprise. Invest in scientific research to improve our understanding of natural carbon emissions, their drivers, and their potential impacts on climate change.
Right now, you're speaking to passionate students who want to actually solve problems like these. What top 3 skills should they study so that they actually have the ability to do so?
Start with skills in ecology and environmental science. Understand the dynamics of ecosystems, the carbon cycle, and the role of natural sources of carbon emissions in the context of climate change. Other skills to address are in climate modeling and data analysis. Master climate modeling techniques and data analysis to quantify and predict the impact of natural carbon sources on the Earth's climate system. Climate policy and advocacy will also be helpful. Learn about climate policies and strategies for climate change mitigation, as well as effective advocacy techniques to influence decision makers and promote sustainable environmental practices.
To understand today's lesson, let's observe carbon in our own lives. Choose a local natural area, such as a park, forest, or wetland. Spend time observing the natural processes that contribute to carbon cycling in the ecosystem. Note factors like plant growth, decomposition, and carbon storage. Reflect on how these processes relate to the carbon cycle and its connection to climate change.
Thank you for taking the How to Solve Climate Change course. If you want to learn the skills to solve this global challenge, join us for free at plato.university for exclusive content, extra resources, and actionable exercises with every lesson. This course was produced by Plato University, where students turn passions into purpose and learn skills to change the world. Learn more at plato.university.